For now, I am copy-pasting parts from my kitbash into my project file, but in the future I will be generating a Blender library so you can easily drag and drop parts into a scene. I am just assembling parts and manipulating vertices when necessary to fit into my design. The development of my kitbash is still in progress, but I've made more than 120 pieces so far, all essential parts for creating robotic creatures in my own style, of course. They are very accurate in functionality, and almost all of them have open and adjustable modifiers for Blender. This means you can easily adjust things like the radius of the bevel modifier or simply manipulate vertices to fit your design. If you're familiar with my designs, I pay special attention to functionality as well as artistic design. In this case, adding a hydraulic cylinder can be a bit tricky because there are many moving parts around. You need to be careful about placement to avoid clipping. The function must be justified as well. Furthermore, the cylinder must not extend beyond its limits. After some trial and error, I found the best placement for it. I ran this experiment in the first place to test my kit and see its potential and its weaknesses and identify areas for improvement. So I decided to design a quadruped robot using only parts from my kit. This is my new approach to 3D hard surface design. While it's not completely revolutionary and has been around for decades, it's relatively new to me. I haven't used 3D kit bashes professionally since I switched from ZBrush to Blender. In ZBrush, using 3D brushes is very common and almost essential. I used to believe in designing bespoke designs in my Blender pipeline until I came up with this idea to generate a personal kit bash that reflects my artistic approach. The parts can be adjustable and flexible to manipulate and adjust based on your needs. I believe this can be the best solution so far. I set up a simple chassis using parts from my kit bash and arranged the rest of the legs around it, just to give myself a good understanding of the final design and to have a better perspective. In the next step, I decided to set up a quick, simple rig to assess the legs in motion and to understand its rhythm and range of motion. The most important thing here is that the root of the joints must exactly align with the center of the joint's geometry. I use simple IK constraint and a damped constraint for the hydraulic cylinders. I will probably make another exclusive video to describe hard surface rigging in Blender in the future. Don't forget to like and subscribe because it was only the beginning. I have very exciting plans for this robot. See you!